Today we're going to talk about radical expressions and rational exponents. A couple of rules we need to recall from the beginning of the year when we were reviewing from Algebra 1 are that when you're multiplying two terms, you need to add the exponents. When you're dividing two terms, you subtract the exponents. And when you have a power raised to another power, you multiply the exponents.
For this example, we're going to be multiplying 7 cubed times 7 squared. Since we're multiplying 7 cubed times 7 squared, we're going to add the exponents. This gives us 7 to the 3 plus 2 power. If we add those together, we get 7 to the 5th power. Plugging this into our calculator, we can find that 7 to the 5th is equal to 16,807. And that's our final answer. For this example, we're going to be dividing x to the 7th divided by x squared. Since we're dividing, we're going to go ahead and subtract our exponents. So we'll get x to the 7 minus 2 power. When we subtract these, we get x to the 5th. And since we can't multiply x to the 5th using our calculator, we'll leave that as our final answer. So our final answer is x to the 5th. Here we have x squared to the 5th power. Since we have a power to another power, we're going to multiply our exponents. This gives us x to the 2 times 5 power, which is the same as x to the 10th power. And that's our final answer.
Proper mathematical procedure to leave a radical in the denominator of a fraction. In order to remove the radical from the denominator, multiply the top and bottom of the fraction by the radical. After you've multiplied the top and bottom of the fraction by the radical, you need to simplify it as much as possible.
In this problem, we need to rationalize the denominator of this fraction. We have a radical 2 over a radical 6, and we don't like to have a radical in the denominator of the fraction. So we multiply the top and the bottom of the fraction by radical 6. This gives us a radical 12 on the top and radical 36 on the bottom. 2 times 6 is 12 and 6 times 6 is 36. In order to simplify this, we need to divide these into perfect squares. So we'll divide the top into the square root of 4 and the square root of 3, and 36 is already a perfect square, so we can leave that as it is. And remember, we divided this into 4 and 3 because 4 is a perfect square. To finish this problem, we take the square root of 4, which is 2, and leave the radical 3 because it does not have a perfect square, and then we take the square root of 36. The square root of 36 is 6. For the last step here, we can reduce 2/6 to become 1/3. So we're left with radical 3 over 3 as our final answer.
The nth root of a real number can be written as the radical expression the nth root of a, where n is the index of the radical and a is the radicand. Find the index and radicand of the 4th root of 64. The index is 4 and the radicand is 64. This table shows multiplying and dividing radicals. When you multiply radicals, you just multiply what's inside the radical sign and then simplify. However, you need to make sure that the indices match each other. If I have an index of 3 and an index of 2, I cannot combine them. The quotient property says that if I have two radicals divided by each other, then I can make that one large radical, or I can undo a radical. If I have the square root of a whole fraction, I can do the square root of one number over the square root of another number.
For this example, we're going to take the square root of 25 over 144. Notice that the square root is over the entire fraction, not just the numerator or the denominator. When we divide an entire fraction, we can go ahead and split it into the square root of 25 divided by the square root of 144. Now that we have this split into two pieces, we can take the square roots individually. The square root of 25 is 5, and the square root of 144 is 12. So our final answer to the square root of 25 over 144 is 5 over 12.
A rational exponent is an exponent that can be expressed as m over n, where m and n are integers and n is not 0. So it's expressed as a fraction. Radical expressions can be written by using rational exponents. The exponent 1 over n indicates the nth root. So 16 to the 1/4 is the same as the 4th root of 16, which is also 2. The exponent m over n indicates the nth root raised to the mth power. So if I have 8 to the 2/3, it's the same as the cube root of 8 squared, or 8 squared, the cube root of that.
For this example, we need to rewrite x to the 6/5 in radical form. So when we do this, remember we want to write our radical sign, put the x inside, and the numerator goes inside with the x as the exponent, and the denominator goes as the index of our radical. So the solution to this would be the 5th root of x to the 6th power. For this example, we're going to rewrite in radical form and then simplify. So for this question, we need to rewrite 8 to the 2/3. So we put 8 inside the radical sign. The denominator goes as the index, and the 2, the numerator, stays inside with the 8. Now we can simplify 8 squared. 8 times 8 is 64. So now we have the cube root of 64. So we have to think, is there something that we can multiply times itself that equals 64? 1 times 1 times 1 is 1, so that doesn't work. 2 times 2 is 4, times 2 is 8. That's also too small. 3 times 3 is 9, times 3 is 27, so that's too small as well. 4 times 4 is 16, and 16 times 4 is in fact 64. Therefore, the cube root of 64 is 4, and that is our final answer. 8 to the 2/3 power is equal to 4. For this example, we're going to take negative 32 to the 3/5 power and write it in radical form and then simplify it. First, we need to write negative 32 inside our radical sign. Because 3 is in the numerator, it goes on the inside of the radical, and since 5 is in the denominator, it goes inside the radical sign as the index. First thing we need to do is take negative 32 to the 3rd power. This gives us a total of negative 3, 2, 7, 6, 8. And we can get that by putting negative 32 to the 3rd power into the calculator. Now, we can take the 5th root and that's going to give us a final answer of negative 8. We can also do this problem doing the 5th root first. The 5th root of negative 32 is negative 2. and then we can cube that, and that also gives us an answer of -8. So you can do either the inside exponent first, or you can do the radical first. Either way, you'll get the same answer. You'll still get a result of -8. This example is 4 to the 5 halves. So first we need to write this in radical form. So we take the radical and put 4 inside. The numerator is 5, so it goes in the inside, and the 2 is the denominator, so that's our index. If we do the inside exponent first, we do 4 to the 5th power and get a result of 1024. If we take the square root of 1024, we get a result of 32. We can also do this by first taking the square root of 4, which gives us 2 to the 5th power, and 2 to the 5th power is also 32. So we can do the exponent first, or we can do the square root first.
Here's a list of all of the properties of exponents that we've talked about previously. These can also be used with rational exponents. You have the product property, which means that if we're multiplying, then we add our exponents. The quotient property, if we are dividing, we subtract our exponents. The power property, when you have one power to another, you multiply the exponents. The power of a product, where if you have a product, you can distribute the exponent back to those products. And the power of a quotient property, which says that if you have a fraction to an exponent, you can distribute the exponent to each, both the numerator and the denominator.
Now we're going to do a couple of examples where we're going to use the laws of exponents. Here we have 7 to the 7/9 times 7 to the 11/9. Since they're being multiplied, we can add the exponents, which gives us 7 to the 7/9 plus 11/9. 7 plus 11 is 18. So we keep our common denominator and get 18 over 9 as our exponent. This reduces to 2. 7 squared is 49. So our final answer would be 49. For this one, we have a quotient, which means we're dividing two numbers with the same base. So we subtract our exponents. So we will get 16 to the 3/4 minus 5/4 power. When we subtract those, we get 16 to the -2 over 4. That reduces to 16 to the -1/2. When we rewrite this, the negative means it needs to go into the denominator of a fraction. So we put this in the bottom and remove the negative. Next, we know that the denominator goes into the index of our radical. So we rewrite our radical and put the 2 in the index. This goes inside, and the 1 goes on the inside. So now we have 1 over the square root of 16. The square root of 16 is 4. So we get 1 over 4 as our final answer. Here we have 5 to the 9/4 over 5 to the 1/4. Since we're dividing, we're going to go ahead and subtract our exponents. So we have 9/4 minus 1/4. This gives us 5 to the 8/4. 9 minus 1 is 8. When we reduce this, we get 5 squared. 5 squared is 25. So the answer to this problem is 25.
At this time, you can continue the practice quiz to practice your skills.